Welcome to everybody. It's Maths and Science by IITian channel. And in this lecture, in linear algebra, about matrices and determinants, it is the second lecture. And in this lecture, we will be taking up in detail about the matrices. In the first lecture, I have given introduction about the matrices, determinants, singular matrix, eigenvalues, eigenvectors, simultaneous equations, number of solutions for a simultaneous equation, and how to find the eigenvalues, all introductory characteristic equation, inverse of a matrix. These things we have spoken about in the introductory lecture. Now in this lecture, we will be taking up in detail about each and every topic. Initially, we will be taking up matrices. Matrices is the plural form of matrix. What is a matrix? It is a array of arrangement of elements in rectangular or square. If m is the number of rows of the array and n is equal to number of columns of the array, m into n is equal to matrix m into n of size m into n. It is a rectangular matrix if m is equal to not equal to n. It is a square matrix if number of rows is equal to number of columns. It is a row matrix if n is equal to 1. Not n is equal to 1, m is equal to 1. Row matrix, single row. Single row, m is equal to 1. It's a column matrix, single column, n is equal to 1. It is a null matrix if all elements are 0. It's a unit matrix if diagonal elements are 1, diagonal elements are 1 and all other elements are 0. A matrix can be, now we define what is a principal diagonal in a matrix. For example, there is a matrix like this: 1, 2, 3, 4, 5, 6, 7, 8, 9. The elements in the diagonal. This is the principal diagonal. This portion is called upper portion, upper triangle, and this portion is called lower triangle. If all upper 1 if all upper triangle elements exist but lower triangle elements are all 0. That means it's a upper triangle. The lower triangle elements are all 0. Like this 1, 2, 3, 0, 0, 5, 0, 6, 9. This is the upper triangle because this portion is 0. Now, if all upper triangle elements are 0, that implies it is a lower triangular matrix. Upper is 0 and lower elements are present. Like this 1, 0, 0, 4, 5, 0, 7, 8, 9. Here upper triangle is 0. Now, what we did not till now, matrix, rectangular matrix, if it is M is not equal to 1, square matrix is if M is equal to N, row matrix if a single row is present, that is M is equal to 1, column matrix if a single column is present, that is N is equal to 1, and null matrix if all the elements in the matrix are 0, unit matrix if diagonal elements are 1 and other elements are 0. For this, it is I is equal to 1, 0, 0, 0, 1, 0, 0, 0, 1. This is the unit matrix represented by I. And these are the different types of matrices. And a matrix can be written as, for example, a matrix is written in this way. It is a vector P1x1 plus P2x2 plus P3x3 is equal to 0. P2x2, sorry, Q1x1. It is not P1, it is Q1. Q1x1 plus Q2x2 plus Q3x3 is equal to 0. R1x1 plus R2x2 plus R3x3 is equal to 0. Then this can be written as a vector P dot vector x, that is equal to 0. Vector Q, vector x is equal to 0. Vector R, vector x is equal to 0. This is the representation of these matrices, 3 matrices. One matrix of 3 by 3 rather is represented in this form as a vector. Now, for example, I have to find out the determinant of this. How to find out the determinant? Determinant is equal to, in the vector form, please try to understand what is the meaning of determinant in vector form. P cross Q dot R. Determinant is a scalar. P cross Q is a vector product into dot R. This is equal to determinant of this particular matrix P1, P2, P3, Q1, Q2, Q3 and R1, R2, R3. This is represented as P1, P2, P3, Q1, Q2, Q3, R1, R2, R3 into this. I will explain you afterward. Don't get confused by this, why I am writing this. Okay. Determinant of this particular matrix, this is the matrix, let me say P. Then P cross R, these are the vectors. P cross Q dot R is equal to determinant of P, that is equal to, what is P cross Q dot R? P cross Q dot R is represented by P1, P2, P3, Q1, Q2, Q3, R1, R2, R3. This is the meaning of the determinant. Please try to understand this. When something is given in the vector form, determinant can be found out like this. Determinant is a scalar quantity. Now, next comes usually once this determinant value can be found out and the simultaneous equation can be solved, major portion of the mathematical problems are resolved. If eigenvectors and eigenvalues are calculated, then quantum mechanics problems, engineering problems are solved. Now, with the definition of these basics, now we will try to understand further. Are there any other types of matrices are there in addition to the whatever we have explained? If determinant is 0, if determinant is equal to 0, then what is that called as? What is that called as? If determinant is 0, we will have multiple solutions for the simultaneous equations. If determinant is not 0, then we have unique solution. That's what we have seen in the first lecture. If determinant is 0, then it is called as a singular matrix. If determinant is not equal to 0, non-singular matrix. If determinant is not 0 means it is invertible matrix. If A inverse is equal to I, then A inverse is equal to inverse of A. I am only telling you different type of matrices exist, so that once you know what type of matrices exist, then we can operate the matrices. on a particular operator. Addition is an operator, subtraction is an operator, multiplication is an operator. Then we can operate the matrices if you know what is that matrix is about. Symmetric matrix, and another one is skew symmetric matrix. There are some special types of matrices are there. Symmetric and skew symmetric. From the definition name itself, you can understand that symmetric means the matrix has elements same in the lower and upper triangles of the principal diagonal. Now, 1, 2, 3, 4, 5, 9. This is the principal diagonal. If we have same elements on both sides of the, here it is 4, no, here it should be, because it is 1, 2, 3, here it should be 1, 2, 3, and here if it is 4, then it should be 4. You just see. The elements on the upper portion 2, 3, 4, lower portion also same. Lower triangle, upper triangle and lower triangle, the elements are same, and it is nothing but a mirror image of each other. Then it is called as symmetric. Skew symmetric means this can also be written as in simpler form if Aij is equal to Aji. What is this one? A11. It is A12. This one A21. A12 is equal to A21. That means Aij is equal to Aji. Ith row, jth column is equal to element is equal to jth row and ith column element. That is symmetric. As far as non-symmetric is concerned, the definition can be Aij is equal to minus Aji. That means the upper and lower triangle elements will be similar but opposite signs. Same numbers but opposite signs. Same we will write 1, 2, 3, 4, 2, 5, 9, 3, 4. But this is negative. If it is negative, this is positive. If it is positive, this is negative. For example, this one, let us say A, third row, second column. This one, second row, third column. A32 is equal to minus A23. That implies Aij is equal to minus Aji. For skew symmetric. For symmetric, Aij is equal to Aji. For skew symmetric, Aij is equal to minus Aji. Now, we understood various types of matrices. One is, and next another one, column matrix, row matrix. Only one column is there, like 1, 2, 3 is a column matrix. One, two, three is a row matrix. Now, we have understood that there are various types of matrices. One is rectangular matrix, square matrix, we list it down. Please, we have to remember them. One is rectangular matrix, you give some examples. Square matrix, you give some examples, it is your homework. Please give examples other than what I have given you. The matrix can have complex numbers also. Square matrix, rectangular matrix, square matrix, row matrix, column matrix. Third is row matrix, column matrix, and another one null matrix, unit matrix, null matrix, unit matrix, and seventh one is lower triangular matrix, upper triangular matrix, upper triangular matrix, lower triangular matrix, next singular matrix, non-singular matrix, singular matrix, non-singular matrix, after that symmetric matrix, skew symmetric matrix, symmetric matrix, skew symmetric matrix, and these are the different normal type of matrices. We can still have more types of matrices which I will be discussing in the next class. Otherwise, this class will be very lengthy. Now, types of matrices we have studied, and homework is give at least 3 examples for each type of above 12 types of matrices. I have given one example. You make some 3 examples for each type of matrix, and as we go further in the technicalities of the matrices, the definitions will increase. Those definitions along with the technicalities I will take up in the next class. Best of luck to everybody. Thank you for seeing my lecture, and if value addition is there because of this lecture to you, please subscribe to my channel Maths and Science by IITian. Please share and subscribe. If you pay attention to minute things for learning without missing even a single word from me in the lecture, then you will gain the concepts and utilize them in the examination. Best of luck. Thank you. Share and subscribe. And in the description I will give link for the playlist Mathematics by IITian. In that I will share all my other videos also, so that You can refer to them. Vectors, we have discussed complex numbers and other topics, which you can definitely take advantage of them and utilize them for getting the concepts clear for your examination. Thank you. Thank you for listening to me. Thank you for seeing my video lecture.